I'm Anil Kumar, and in this video we will see slope of a tangent on a curve, which is a very special curve. It is a semicircle. Question here is, determine the slope of the tangent to the curve y equals to square root of 25 minus x square at 3, 4 using properties of circle. Now we'll also find slope of this tangent on this curve using limits or difference quotient method. But in this case, let us explore and figure out how to find the slope of a semicircle, of a point on a semicircle, using the techniques learned already. It's kind of a review on tangents. So let me sketch this. We have a function here which is y equals to square root of 25 minus x square. As you can see here, the domain of this particular function is that x should be greater than or equals to 5, right? Minus 5, absolute value of x should be within 5. So greater than or equal to minus 5 and less than or equals to 5. So that is the domain of this particular function. And the range here is that since it is square root, so minimum x could be 0, for example, minus 0. So it will give you a maximum value of 5. Anyway, if you square both sides, then you can also write this function as y square equals to 25 minus x square. Bringing x to the left side gets you x square plus y square equals to 25, right? So that is the equation of a circle. Now, since we have square root, we are only considering where y is greater than equal to 0, right? So not the negative values. So that makes it a circle, a semicircle, right? So we could draw this semicircle kind of like this, where these points are at 5 and minus 5, and the vertex, if I substitute here 0, you will get 5. Positive, we are looking for values, correct? Now we are given a point 3, 4. Point 3, 4 could be, let us say, here, and we want equation of this tangent line, basically. Rather, it's only the slope of this tangent line at the point 3, 4. So how are you going to find this? That is the question for you. Now it's kind of a pre-calculus question. You should know that perpendicular lines have negative reciprocal slopes. That is how they are related. And since the origin is the center of this semicircle, we can drop a perpendicular from here to the point, and this will be actually tangent, will be perpendicular to the tangent. And by finding the slope of the radius, we can find, by the segment from 0 to, let us say, point P, we can find slope of the tangent line, correct? So we can say that slope of line OP is y2 minus y1 over x2 minus x1, where y2 is 4 and y1 is 0, right? So this point is 0, 0, correct? So I hope now you get it. It should be 4 minus 0 divided by 3 minus 0. That is to say, the slope of OP is 4 over 3. Now, since the tangent should be perpendicular to OP, right? So we know tangent is perpendicular to OP. So slope of tangent will be negative reciprocal, which is minus 3 over 4, correct? So that is how you could find slope of the tangent at a given point on this function, right? So that is how you should be doing it. Well, you can also look into how we find slope using difference quotient method. Thank you and all the best.